everybody, we're here today to talk about sequences. A sequence, at least in mathematics, is a series of numbers that has some sort of pattern to it. These are some fairly simple sequences. You can see the pattern in the first one, I hope, fairly obviously. And in the second one, if you've gotten anywhere past perhaps the first, maybe second grade, you should be able to see the pattern in that sequence as well. You may have seen the last one here as well. It's a very famous sequence that's gone down through the years called the Fibonacci sequence. And I'll leave it to the viewer, if you haven't seen it before, to try to figure out how it is we make each of the next numbers and maybe try to guess the next one. Now, before we can speak intelligently about sequences, we have to have some terms, so to speak, in common. The term in a sequence is which particular number you're talking about. And we use the variable n to tell us, I mean this term. So if n is 2, we mean the second term. If n is 5, we mean the fifth term. A is the variable we use for this is what the term contains. So a sub 1, hear that carefully, a sub 1 means the first term in the sequence, whatever starts the sequence. In that first one we had, it would be 1. A sub 7 would mean the seventh term in that sequence. A sub n then means the nth term, which means pick a term, whichever one you're talking about. It's the nth one, it's that one. It's sort of a generic way of saying, here's a term, let's think about that one. And a sub n minus 1 meaning before, means whichever term I'm looking at, a sub n minus 1 is the one from before that. Now, the sequences that you saw before were pretty simple sequences. You can very, very easily figure out what the next term is. Sometimes sequences get a little bit more complicated, and if they get it all complicated, we want to be able to mathematically define what the sequence is. And there are two methods by which you can define a sequence. The first is called recursive, and what that means is you have to know the previous term in the sequence, whatever came before, in order to make changes to it to turn it into the next term, the one that you're interested in. So you have to have a first term to have the next term. You have to have that next term to create the term after. The other way you can build a sequence mathematically is explicitly. And explicitly means all I need to know is where I am. Which term am I? The nth term, which one is that? Do you want to be the 7th? Do you want to be the 9th? Do you want to be the 50th? Take that number, 7, 9, 50. Make something happen to that to create the term that you're interested in. It wouldn't matter what the previous term was. I can get directly to any term using the term number, the n. Recursive, I have to know the previous number to get to this one. Explicit, I can get to any number I want. Now, recursive is pretty simple. Find the previous term, make some changes to it, get to the next one. But explicit sequences, there's several different ways you can do them, but there are two that are really, really, really the most common. An arithmetic sequence takes whatever the previous number was and adds something to it every time. Write this down because this is the formula that makes an arithmetic sequence explicitly. You want to know a term? Take the first term and add to it your term number minus 1 times whatever the common difference is, the amount that's getting added every time, or subtracted every time. It may be adding negative. You want to know any term? Start with the first one and take what you've been adding every time times 1 less than whatever number you're trying to get to. The other kind of sequence is a geometric sequence, and different from arithmetic, you multiply every time you get to the next one. So in arithmetic, it might be 2, 4, 6, 8, 10. You're adding 2 every time. In geometric, it might be 2, 4, 8, 16, 32. You're multiplying 2 every time. There's a way to define that mathematically as well. You want to know a specific term? Take your first term and multiply it times the amount you're multiplying by every time, taken to the power of 1 less than the term that you're getting to. A geometric sequence, you can define any number in that sequence by taking the first term times the common ratio to the power of n minus 1. So I have up on the screen some sequences. Specifically, I have some mathematical descriptions of some sequences. And what I want to do is I want to see the first 5 terms of each of those sequences. And I want to determine, is that sequence a recursively defined sequence or an explicitly defined sequence? Let's take a look at the first one, what we know, and let's see what we can figure out. It says right there that a sub 1 is 1. That means the first term is 1. That was not hard. Now what it says after that is that a sub n, any specific term, is 4 times the previous term minus 1. If I want to know the second term, the previous term was 1. So according to that description, 4 times the previous term, which would make 4, minus 1 would tell me the next term. It's 3. The next term, a sub 3, is going to be 4 times the previous term minus 1. 4 times 3 would make 12, and 12 minus 1 would make 11. This term will be 4 times the previous term, that'd be 44, minus 1 makes 43. And the final one, 4 times 43, 172, I believe, minus 1 will make 171. Sorry, I wrote that wrong. So is this a recursive or an explicit function? Well, since the description used the previous term to get to the next one, and it never actually cared whether I was at the second term or the fifth term or the ninth term, all it said was look at the previous one. That makes this one definitely a recursive. Let's take a look at the next one. It's telling me the first term. I bet that means it's a recursive, because it wouldn't need to tell me the first term if it was explicitly defining each term number for me. And sure enough, it says here that each term is the previous term plus 11. 3 plus 11 would make 14. 14 plus 11 would make 25, etc., etc. This one's absolutely a recursive function. Let's look at the next one. This one doesn't tell me the first term. I can't just drop in a sub 1, because I don't know what it is yet. And I see that the function has 12 times n minus 2. It uses n. Sure, this one says n as well, the one above it, but it's using n as a subscript, as an identifier. It's saying the previous term. This one says use that term number. The first term on this one is 12 times the first term number, which is 1 minus 2. 1 minus 2 makes negative 1. 12 times negative 1 would make negative 12. And just to show what it really means to be explicit, in the case of the recursives, the one above it, I can't tell you what this one is yet. Not till I know what this one is. But in the case of number 5, where it's an explicitly defined function, oops, I gave something away, I can get to the fifth term straight away. You want to know what it is? It's 5 minus 2. That's 3. 3 times 12 makes 36. And there's your big clue. If you can define any specific term without having to know the previous one, you've got an explicit function. If you need to know the one before it to find the next one, you've got a recursive function. And in those functions, if it says a sub n minus 1, that means whichever one you want to know, go find the one previous and plug it in. And if it just says n, that means you want to know this one, then you plug 3 in where n is, because that's the third term.
Don't bother me, I'm working.